Hey, good morning, David. How are you? Welcome back. Another week has gone by. Always,
Yes,
time
yes.
seems to fly.
That's because you do nothing other than look forward to this podcast all week.
Of course not. This is what I love doing. I mean, come on,
Yeah.
what better way to spend our week, gaining more information that we can share with everybody. And of course, I look forward to the shirt.
Yeah. Thank you. This one is by the Pacific Whale Foundation. They did a collaboration. So if you're ever in Hawaii and you want to go whale watching, do it with the Pacific Whale Foundation. They have a great mission and super smart, educated scientists who take you out on boats to find whales. That's my
Oh, interesting.
unplanned plug for the Pacific Whale Foundation.
I am
So
sure they would appreciate that. Moreover, I'm really
yeah,
sure they appreciate you wearing their shirt. But
exactly.
so so awesome. Like I look forward to this chat like I always do. And hopefully we can make it fun. And like I like to say to everybody else, questions are welcome. I think questions make the conversation better. If you have any questions, please post them. Dave and I have obviously we've done a number of these over the last couple of months. We're still getting better and we're trying to get even better at it. But we find that questions obviously, you make the conversation, and I think any questions that come as part of this are always super helpful. So please engage online and or offline. We love the questions.
Yep, yep, we do. And hopefully there will be interesting questions about today's topic because it's something that I suspect most people who are listening have been hearing about this for a while. So our topic today is agentic AI.
Yes, agentic AI. What is it? I mean, and I know you and I probably have said this because we brought it up in front of customers, but what is agentic AI? And I think we should, let's at least start with a definition of what agentic
Yeah.
AI actually is and why you should actually care about this.
So first of all, it's such a funny name. Like when I hear about agents, the first thing I think of, and maybe I'm dating myself here, but I think of like Agent Smith chasing down Neo in the Matrix movies, right? Um,
Yep.
which is actually, funny enough, not the worst analogy in the world because Agent Smith is actually behaving as an agent, and
Yes, he
I'd like
is.
to think that the scriptwriters named Agent Smith not just because he was dressed like an FBI agent, but because there was some aspect of AI software agent in the storyline, because that's certainly the way he behaved. So let's
I would
talk
hope.
about what it means, right?
Let's yeah, no, let's talk about what it means. But first, I think history is always warranted. I think it puts things in
Yeah.
perspective. And rather than jumping into the current version of agent or agentic computing, let's just speak kind of how we got here a little bit, because agent computing is not new by any stretch of the imagination, and in fact, it's been around for decades. Just the previous versions were, very rigid. Uh, and not with the flexibility of today's agents, and they were rules based. And if the rules were different, or reality changed, they didn't respond accordingly. But they were very rigid in their approach, and unlike today's agents, which have a lot more capabilities and power.
Yeah, and in fact, a lot of times the more historical version of agents were also what rules-based systems, expert systems. There were other
Yes.
names,
Yep.
and I think you're right. It was all about they were designed to do something. They were designed to take some input and do some action and produce an output. They were sort of the
Right.
mathematician might call them finite state machines,
Yep.
right? And
Yep.
powerful at the time, but I think, as you said, they were brittle, right? Like if they got
Right.
unexpected input or encountered a situation that they hadn't been configured for, stuff happened.
Yeah, no, I remember writing an agent-based trading system. God, almost 20 years ago, dating myself now, using a an algorithm, it's in fact called Reedy, which was an old algorithm. It was intended to be artificially intelligent. It was a way of making systems smart at the time, but while it was highly scalable, you basically define rules for input, and this is what the output we're doing was a declarative programming model. It was rigid, and you can have massive number of rules to try to identify every single case that was out there. And if things went awry, they went awry. And that was it. And again, very rigid systems worked great in certain cases, but not very flexible. Not like today's systems, which are highly flexible and much more goal oriented.
So
Right.
yeah, I like that phrase goal oriented because that to me really sums up what it's about. It's funny because you don't necessarily think, or I wouldn't necessarily have thought probably a couple of years ago that it was going to be large language models that actually enabled agentic computing because on the surface the two don't seem very related to one another. But
No,
they are.
no, they're very closely related. No, they're not. And I never would have called this, and I never would have thought about this because, again, we were so enamored with Gen AI and just language models in general. Gen AI, I think, kind of creeped up on a lot of us. And in fairness to most companies, I don't, while there's a lot of conversation about it now, I don't think most people are actually prepared for it. But we'll discuss some of the potential use cases where we think it can be utilized. But, there was a phrase that I came across yesterday when I was preparing for this that I thought was a very good way of very succinctly saying what is an agent. And agentic AI is simply proactiveness. It's being proactive, it's being goal oriented. And I think that's what is the differentiator between agentic AI and just generative AI or LLMs, just in general, which are reactionary and respond to a prompt of some sort. Right,
So before we go deeper, let's pick apart those two things, the proactive and the goal oriented, because I think those probably are the two most important concepts for people to understand.
right,
Proactive, I think, is a good word because if you think about a large language model, right, if you're opening up ChatGPT and you're not using any of the agentic tools, you're typing in text and you're getting back text, or you're typing in text and you're getting back images or video, but you're just getting content back. Nothing
right,
happens in the real world, right? You're
right,
literally just getting text, and then you may cut and paste that text and put it somewhere and do something with it, but nothing's happening. So that is not proactive. When we're talking about agents, we're talking about using AI technology in a way that it actually makes something happen in the world. It actually achieves a result, right? It's
right,
not just giving you back text. And we'll talk about this as an example, but maybe it's booking you a travel reservation, or it's making a purchase
right.
on your behalf, or it's doing some other thing. So that first component of proactiveness is it's actually effecting a real change in the real or digital world beyond just giving you back some text or some other output that is generated. Is that a fair description?
That's a very fair description, but I want to take that slightly further. And I think this is also important to add. It's taking feedback and adjusting accordingly. So, and it might be taking in information from external systems and adjusting accordingly. So I think I want to go back to your example, and this is the common example. And this is actually something that you and I, when we first started out, we had this conversation,
Yeah.
pre-agentic talk computing, about doing travel planning. And you and I learned for the first time the complexities of doing B2B business travel, how hard it actually is, and how many variables go into it. If you want to book a travel, so if a company wants to book travel for, say, 50 employees, there's a lot that goes into that, and there are firms that specialize in doing that business to business travel, something I had never, and you and I had never heard of before. Um, but, you know, putting into a model, I'd like to book travel for 50 people in the following cities. You think about that. What goes on behind the scenes is actually very complex. What a human would do. Anything from looking at availability in rooms, thinking about it out, coming up with, financially what makes the most sense, planning for restaurants, booking travel, booking buses, doing all this stuff on all these different places, and then adjusting based on feedback from other agents and making decisions accordingly before it actually completes the task that you want it to complete.
So that
Right?
sort of gets into, you mentioned earlier, goal seeking, I think was the way you put it, right?
Yep.
And or goal oriented behavior. I think what you're describing is that goal oriented behavior, right?
Right, exactly. And that's a differentiator between generative AI and large language models is the agentic side. It's looking to do something proactively to complete a task for you, given that there's a lot of variables that are occurring. And those, look, the real world is fuzzy. Things happen all the time. It's not like a rules engine, which has, a very if this, then do this. Reality is, as we both know, um, interesting at all times. It's fuzzy. These things are not, always cut and dry, and it has to make decisions accordingly, much like a human does, and it's trying to mimic what we do.
So all of that makes sense, but yet I keep seeing all of these software products and all these services and everywhere else that, now it's like they're touting agents and agentic on their websites and their product literature. Would you agree that there are a lot of things sort of being labeled as agents today that really don't meet our criteria for real agentic behavior?
I'll take that a little step further,
Okay.
because I think we should.
I
I
put
think
I put the
most
bait
of
out there for you.
Yeah, you know me. I'm never going to stop. I'm going to keep going. I tend to be the one that's a little skeptical of a lot of which gets said out there. So let's start with the obvious. Most AI platforms out there, or most that are advertising to have AI in them, do not, or they're using it on the edges and very little of it, and making a call into one of the foundational models, and a very limited capacity, but not truly deeply using artificial intelligence or large language models in a way they really, to get the most out of them. Agentic AI, just throw it on top of that. I think unfortunately it's become a buzzword for a lot of companies, and they're not really doing agentic AI. And a chatbot to me is not agentic AI, though it might be labeled as such. So unfortunately, it's become, I think, too much of a marketing term, and not a real agent AI. In fact, most people don't really understand what it is in the first place.
Right. So that's it. And let's use the travel example to dig into it. But I think that's an important point too to underscore is that there are a lot of things that are labeled agentic that aren't truly. And if it's just a simple chatbot, it's may not be agentic. There could be agents happening behind the scenes that
Right.
interact with the chatbot, but just a chatbot itself is not agentic, nor is just a workflow. I think that's the other thing I see is a lot of
Right.
companies are building some form of multi-step workflow into a process, and they're now calling it an agent. If I sign up for a new
Correct.
software as a service and they've got a 5-step workflow that takes me through the sign up process, suddenly they're saying, here's our sign up agent, right? And
Right.
if it's just executing the same process every time or the same process with some simple branching and decision logic, that's not an agent.
No, it's not. And it's not at all agent computing. I mean, agents, um, they have to, and just to differentiate a little bit further, and I know we're want to it's sometimes not 100% clear about it, like what is the real difference here, but an agent should operate with autonomy and intention. It's very different than you're going through a workflow that's been the same workflow that's been around for 10 years, and now you're calling it agent workflow, or maybe you put some AI on top of it a little bit. But if these agents have to operate with autonomy, they have to have intention,
Yeah.
and in many cases they will pull information from external systems to adjust their behavior, their chain of thought reasoning, their reasoning capabilities
Yeah.
as they learn and adjust accordingly. That's an agent. An agent's not a rules-based piece of software sitting over there doing the same thing it's always done.
Right. And I
Right.
think let's pick apart that word intention. I love that word. I think it's a great way of describing what an agent does because when you ask an agent for something, you're not telling it how to do the thing. You're just describing the thing you want done. And
Right.
here's a real simple example. A non-agentic example. So to be clear, I'm going to start with something that's not an agent. But if I have a large language model and I give it a bunch of raw meeting notes and I say, please turn this into structured meeting notes with some, action items and follow-ups,
Right.
right? I'm not actually telling that large language model how to do it. That's an important
No.
distinction. If I were doing this on my own, writing code or a macro, I would give it very precise instructions. I would try to figure out how, I'd look for certain words or phrases that indicate something's an action
Right.
item. I would look, right? You don't have to do any of that when you're asking a large language model to do something. So in a very little basic way, you're kind of already doing a little bit of intention setting when you use a large language model to do something. But that's important because you're not, with an agent, you're not saying how to do it. You're just saying, here's the outcome I'm looking for. Here's the goal you should solve for, right?
Right. Right. And it's a difference between proactive and reactive. Whereas a language model, when you're inputting information, it's reacting to you and the input
Yeah.
that you give it, the prompt that you give it, as opposed to being proactive at solving for a goal, for an intention, finding something that needs to be done and adjusting accordingly, much like a human would in a complex situation. We adjust
Right.
based on information that we receive, and we make decisions based on the information we receive. And in cases where things go sideways because something was not expected, we will adjust accordingly. And in many cases, these agents, these complex pieces of software, can do something very similar. Now,
Right.
there's a lot more to it than obviously that, but that's the gist of what an agent is.
So should we go back to our travel example and maybe even just to keep it simple, we'll do a very simple travel example, but let's use that to kind of dive into how do these agents work, like under the covers? What are the different parts and pieces of this agent?
Right.
So let's see. Let's take travel. I think it's a lot of people use travel when they're describing agents. We'll do the same because honestly, everyone can understand. Everyone has felt the pain, the challenges of trying to book travel. You know what a pain it can be at
Right.
times. So I want to go from here to Los Angeles. I want to be there for 3 nights. I want to have 2 nice dinners out. I want to stay in a certain type of hotel, right? Whatever. Maybe I need a rental
Right.
car. And you all know the way you do this when you're booking in person, right? You're bringing up Google Flights or your trip planner of your choice. You're looking at this
Mm,
airline versus that airline. You're like, well, if I change my flight and leave on Tuesday instead of Monday, I get no connections at a better price. But then I'm going to end up paying more for the hotel because I'm staying into Thursday, and the hotel goes up on Thursday, and you're sort of you're solving
right.
multivariable calculus, right? You're solving for convenience, you're
Basically.
solving for your personal preferences, you're solving for price, you're solving for timing and other dependencies, resource constraints. Maybe there's not a rental car available on Monday, but there is on Tuesday, right? Like, it's actually
Right.
pretty complicated when you think about what you're trying to do.
No, 100%. And what you described is actually a fairly simple trip. Imagine
Right,
doing a multi-city trip across Europe,
right,
multi-country, multi-city trip, and you see how fast the problem actually blows up
right.
and the complexity of planning that.
Yeah. And then maybe you're also saying, well, I want to visit this office one day and that office one day. So now you're going to start to figure out, okay, who's available which day. And maybe that changes where you want your
Right.
restaurant reservations that night. And so there's all this web of interdependencies. I don't know
Right.
about you, but if I were just trying to, in traditional procedural code, write an algorithm for solving this travel problem, it's actually pretty tough, right? Like,
It's actually very tough. I
yeah,
honestly, I'm not even sure you can. I don't say you can't do it, but it's going to be a very complex problem to solve with traditional code. And again, not unsolvable, but certainly very difficult.
there's a reason I procrastinate when I have to plan travel because
Oh,
it's not a fun thing to do, right?
I,
It's miserable.
I was, no, it's horrible. I was planning a trip to Europe last year, to Greece and to France, and the amount of time spent online, we finally threw up our hands and said no, let a travel agent do it because it was just becoming too complex, too fast, and never mind trying to book flights to multiple cities,
Right.
in small airports or in places where there's not a big airport or this or that, or I mean, the complexity grows out of control. And if anybody's traveled to Europe, you understand rapidly how fast it gets way complicated.
Yeah. Okay. So we've established that this is a big, complicated, unpleasant task.
Hairball. It's a big
Yep.
hairball.
And it's ostensibly, I think our next task is to say, why is this a great example of what an agent could do and how would an agent approach this? Does that sound
Right.
fair?
No, it sounds fair. That's a good approach. You're trying to mimic human behavior.
Yeah. Yeah. All right. So what?
So let's
How would
start
an
with that.
agent approach this? How would an agent start? Like,
I mean,
what's
uh, what's the agent's going to speak to you or me, and they're going to get, Peter David, what do you want to do on this trip? They're going to get an outline of what you want to do and kind of we'll give them some boundaries. Like I want this date to this date. I want to spend this much versus this much. I want a, 5-star hotel versus a 4-star hotel. I want these types of restaurants. I want local restaurants. I want local sites. I want places that people don't typically go. I want places that I wouldn't find on Expedia or someplace else. I want the little tiny place someplace that nobody knows about.
okay?
Um,
So
you know,
first, you're having we'll say a conversation with the agent, and we say
right,
the agent, but really at this point, you're having a conversation with a large language model that is basically helping you to clarify and define the goal. What do you
right,
want? What are
exactly,
the constraints? What are your priorities, etc. All right. So now,
right,
now you've got a goal, and now some specialized models come into play, right? Like things like the plan composer or the orchestrator and some of the specialist agents.
right,
So let's talk about what
right.
happens next.
Now there might be there, right. As you started to breaking this down, there are components to um, bringing agents together because they clearly have to communicate together at some level, and you got to share information. And there's a protocol for that as well. But there are also, frameworks out there that you can do your own. You can roll your own, or you can use a framework to orchestrate the communication between the various agents that are there. So you might have an agent for doing nothing but booking flights, an agent that's been tuned, fine-tuned with flight information, so it is very capable of looking at flights and making adjustments and booking flights because it's been trained for that. It understands, how to make those decisions. It understands maybe how to communicate with, say, Google Flights or all the airlines. So it's capable of bringing in external information into its thinking to adjust accordingly. You might have another agent to book hotels that's capable of booking hotels on another platform. So maybe it's has API calls into all these various travel platforms across the world, and it can query them and get back information for you. And maybe you have similar things for booking train tickets or booking the local sites or whatever it may be. You're going to have individual agents, but then you have to bring it all together into cohesive itinerary for an individual.
Yeah. So let's use an analogy of I like the analogy of an office. Like we talk about the agent is doing this for me, but the reality is it's a team of agents, right? It's a little swarm of agents doing stuff for you.
Yes.
And you can almost think of it like an office, right? Because that agent with whom I'm having my initial conversation saying, here's the goal, think of that like the team leader, right? That team leader goes and creates a plan. It's the composer or the orchestrator, and it creates a plan.
Right.
And it identifies that you need a bunch of other worker bee agents or specialist agents like you described to go out and do
Right.
specific things. So rather than saying, Bill over there, you plan this trip, it's saying, Bill, you're in charge of flights. Betty, you're in charge of cars. Lou, you're in charge of hotels, etc., etc.
Right.
And they go off and they do their thing. And the
Right.
really important thing is each one of them goes off and has some, as you alluded to, they have some either tools or domain knowledge about that task they're supposed to do. So they go off and they do their
Right.
thing, and they report back. But it's that team leader, orchestrator, or composer that sort of says, okay, but your flight dates don't match with these hotel dates, or you offered me
Right.
3 flights, but which one matches with the hotel, right? And sort of does a number of things. It gives feedback and sends the agents back out to do more work. And
Right.
ultimately, it decides when you're done, right? It says,
Right.
okay, this is good. We have everything now. And then goes back to the user and says, hey, we're done.
Right. And it presents it with the itinerary. And yeah, I think you're right. I mean, these agents, and again, this is important. They're adjusting based on feedback, and they could adjust accordingly. But a couple, I think, key things, and you had said it yourself, is in many cases they have more domain knowledge. They're tuned for what they're trying to do. It's not just a generic foundational model in most cases. And I think even moreover, more importantly, they have links to external systems. And when they get information back from those external systems, they can go through their, we'll call it thinking, but maybe a chain of thought, maybe it's a reasoning model that's on the edge here. It's something else, but it's reasoning, capable of reasoning based on these inputs. And
Yeah.
at the end, you have, like I said, you have an orchestration layer. In many cases, you have a shared memory, possibly too, across agents. So you're basically sharing information so that you can then make a final decision. You can bring it all together and present the user with a response.
So I'm going to pretend that's the whiteboard on the office wall where all the specialist worker bees come back and like write their intermediate results on the whiteboard
Right.
so they can see it and identify
Yeah,
conflicts and things. Yeah. And
exactly.
what's interesting is each one of these agents that we're talking about, whether it's this composer slash orchestrator agent or it's one of the
Right.
specialist agents, they're large language models. That's all they are. They're
Right.
specialized large language models
Right.
with
Right.
as you said, sometimes some specialized domain knowledge or awareness of APIs or not, right? Depending on and what we can talk
Depending on the
about some of
model.
the constructs, yeah. But
Right.
it's really just sort of a network of large language models conversing with each other.
Right.
And here's what's super cool about it. In traditional computing, if you wanted computer module, software module A to talk to software module B, you had to predefine that interface language. It was
Right.
going to be
Correct.
through a function call or an API call or something, but it was very rigid and clearly defined.
Right.
These agents communicate to each other by generating language. In the case
Right.
of most agents will say it's English language, but it doesn't have to be, obviously. But they just generate language. And
Right.
so, in some way, they really are like workers in an office who speak to one another and understand one another and respond and react to what they're being told by the other agents in the office.
100%. And I think that's actually a great way of looking at it.
Yeah.
Because if you think of what does a travel agent at the end of the day do? Pick up the phone and call people, or send email or text or whatever it may be. But effectively, they're communicating via language and bringing all that information together to generate an output. So you're basically doing the corollary of using, large language models, or, again, there might be a specialist in, the individual who knows how to book flights and who knows how to,
Yeah.
get the most out of an airline. And there's somebody who knows hotels in Europe and some town in Italy. And you're going to call them to book flights, and that's their specialty, and you're going to rely on them. No different with agent or agentic computing. It's really kind of a goal oriented. You're trying to solve a problem, and you're having all these helpers who are domain specific or domain experts bringing it all together.
And then the last part of the equation, and we'll come back to this in a second, but is that just like your example of a travel agent or my example of workers in an office,
Right.
those workers use tools to do things.
Correct.
And that's some of what specializes those workers, is which tools they might know how to use.
Right. Right.
Right.
Exactly. And I think let's take our travel example again. You're done. You like what they proposed, and you said, "Good, that's great. Book it. Now go." And with those specialized tools or those specialized APIs, it will call the agents and say, "You go, you go, you go, you go," and we're done. We now book the trip, and Peter and David are going traipsing across Europe.
So can I do a really simple example of an early, I'll say kind of a prehistoric or early version of agentic computing. And by prehistoric, I mean 6 months ago. Or maybe it was 5 months ago, right? So,
Yeah, well, 2 weeks ago is ancient these days with this stuff.
yeah. So I was using Anthropic's computer use model. It was
Mhm.
probably 4 or 5 months ago.
It
And
was because I remember when you were doing this.
yep. And it was really interesting. So the way it would work is
Yeah.
you would set this up, and it would spin up like a little virtual computer environment where you had a web browser, and I would type and say what I wanted, and I said something like, "Hey, get me a dinner reservation for 2 people at a 4-star restaurant, and I like this kind of food, this
Right.
kind of food, and that kind of food, and here's the dates I want." And the way it actually worked was interesting because, okay, I was talking to the coordinator, the composer, and then
Hmm.
there was actually what the model did was actually very interesting. So first of all, it made a decision. It said, I didn't say
Right.
use OpenTable or Resi or some other booking service. It actually did that. It actually
Right.
figured that out. Now, it figured it out in a couple of different ways. The first thing that these original agents did was they often took a screenshot of the virtual computer they were working on, and they analyzed
Right.
the screenshot, right? They used an LLM, and
Right.
it said, oh, look, here's the following icons and bookmarks that I can see, and one of them was OpenTable. And so it
Right.
then told the computer, okay, move the virtual cursor this many pixels to the left and this many pixels up, and do a virtual
Right.
click. Right, and once it was done, it took another screenshot, and it said, "Oh, now look, here's a screen, and there's a field over here where you put in the date, and there's a field over here where you put in the type of cuisine, and then
Right.
here's where you put. I check this checkbox to say use near my current location," and
Hmm.
it told the tool controlling the virtual computer. So it had a tool, and the tool was like
Yep.
remote control of the virtual computer. It said, "Move the cursor to this location, check the checkbox, move it to that location, type in this date, etc.,
Right.
etc." And it just went through this really time consuming process of taking a screenshot, looking at it, deciding what to do, and then telling an agent to actually do things on this virtual computer,
Right.
waiting a few minutes or a few seconds, taking another screenshot, and deciding what to do.
Right.
I mean, it's absolutely fascinating, very limited, because the only tool it had
Right.
was remote control of a browser.
Right,
That was
exactly.
it.
And I remember when you showed me this for the first time, I was intrigued. I thought it was fascinating because it was taking an image and it was understanding what was in that image, and it was adjusting accordingly and filling in the necessary boxes. It had no concept of what was on. Again, that open table could have been laid out any way possible, yet
Yeah,
it's smart enough to read the image, go through image processing, I do object detection, whatever it was doing behind the scenes, and say, oh, hey, that's the name, or this is this, and this is the date field, and it was just manually inputting stuff. Fascinating, not scalable, but
not
fascinating.
scalable.
Um, but
But what you
no,
said was very interesting. You said it could adapt to changes in the open table, in this case, website.
right,
100% true. And this is, even though it was crude and it wouldn't scale, that was showing some of its power, because a traditional
right,
system, if OpenTable changed their UI or changed the size of a field or something, would break. in a traditional rules-based or expert system.
Right.
Right.
Yeah, RPA, for instance, is going to break in many cases if things change,
Absolutely.
which I think is a good, it's the classic example. It just, this is very flexible in its approach to dealing with changes in reality, which happen all the time.
Yeah.
Um, but so again, I want this is where it's fine. We're talking about the booking and booking of restaurants and traveling, but in the real world, when you were working in a business,
Yeah.
what is the value? So I'm a senior manager and I'm looking at this stuff going, that's great. I love traveling. Why do I care about this when I'm building out a data platform? I'm building out a platform, and how is this going to help me in reality? What is the real business value behind this?
Right. So I think the business value, I mean, it's funny because you could almost quip that it's sort of limitless. Um, because if you
Yeah,
think about how much time people do doing things that they know how to do versus thinking about what to do, right?
right.
That time that you spend doing things you already know how to do is ripe for some form of automation and digitization. And agents are one
Yes,
of the ways you could do that. And
yes,
so I think whether it's a process of client onboarding and signing people up for new accounts at your company, or validating orders and confirming people's shipping addresses, or all sorts of things. Think about what we do. We receive an instruction from someone, from a customer, from our boss, or whoever. We think about
right,
how we're going to do it, and then we use some tools and we do those things. Those are
right.
all
Exactly.
processes that could be, in theory, automated as agents get more powerful. Now, agents aren't thinking; they're planning, but they're not truly thinking. So the work where we're like, I've never done this before. I wonder how we should approach that. That's probably not a great place for an agent. But
No,
if an agent can read your instruction manual, look at the policy document, look at some tools that are available, and say, okay, here's what I think we're going to do, that's something an agent could probably handle for you. So I know it's an
right.
open-ended answer, but I think there's so much that an agent can do.
No, I agree. And there's also the concept, and I don't want to overlook this, and we forgot to mention, of the human in the loop. And, because there are cases when you certainly don't want an agent making a decision on your behalf, maybe making a recommendation, you do have, or you want input from a human before it completes it. You couldn't have the human in the loop, and there are frameworks that support this human in the loop concept to come back, or you say, hey, you know what? I need a response here before I can go forward,
Yeah,
in the form of, I call it augmented intelligence or augmented AI or whatever you want to refer it to,
yeah,
but it, guaranteeing that somebody's overlooking it to make sure that it's doing the goal that it's set out to actually do. It's funny because you look at it from that perspective. I look at it from a data engineering perspective, and I think, and there are cases that are projects that you and I have spoken about and worked on where the potential exists to have data sources from 100 different systems, many different types of formats. And if you're going to do that in a traditional approach of data pipeline engineering, it's costly and slow.
mm-hmm.
And, especially if I want to scrape a website, or I want to pull up other types of information, or I want to get something that's non-standard, or maybe even a different language, having agents that could, or agentic data pipeline or data engineering infrastructure is going to allow for scalability, flexibility in a way that traditional data pipeline engineering is not going to. And I think that to me is incredibly valuable. Look at problems and how would you solve them differently to get more out of them. And I think
Yeah,
that to me is one of the uses for agentic computing, and we've made recommendations to do stuff like that. In fact,
right. I mean, I love that example, and I think if we're talking about it from a software development and a data engineering point of view, here's the difference. You could use a current AI coding workbench to say things like, you know, give me a call to this database and return these fields. Great. Okay, that's
right,
fine. It can automate that. It'll figure out how to generate the appropriate connection strings to the database and the SQL. But what if what you actually wanted to say was to actually say, in business context, go
right,
find me new customers in category B who have had activity in the last 6 months, right? Now,
right,
that's business definition. You're not you the cursor.ai or any coding workbench,
right,
GitHub, etc. They're not going to know how to translate that into SQL queries and parameters and search criteria. But
right,
if you had an agent that was aware of and tuned to your business rules or tuned to your customer activity database or your orders database or something, you could actually, in theory, say to that agent, I want active customers in this category. And that agent behind the scenes knows how to translate that plain English request into the appropriate technical criteria to go and get that data for you.
Right.
So
Right.
that is
Right.
interesting
Exactly.
because as a coder, you now have to understand the process and describe the process of your code, but you don't have to know the technical details of how that database is structured and what fields even exist in that database.
Right, exactly. Well, I think the beauty about some
Pretty
of
cool.
this is, I think I don't want to say people, employees get a little, I don't say freaked out is probably the wrong way. These are going to take over my job. I can't do this. I think what it forces you to do, you're working on the high value tasks and not the lower value grunt type work that typically you spend an enormous amount of time on. So rather than thinking about, oh, I have to move, this from point A to point B, I'm actually doing the work that requires high level thought. I'm thinking about the bigger picture. I'm doing things that at least are in many cases much more valuable to an organization and free me up to do those types of things. And not always the grunt type work. And that's also an important outcome of this.
An economist said, and I won't try to quote it directly because I would butcher it terribly, but basically said that we shouldn't be afraid of making people more efficient because it's not going to mean that we need fewer people. It's going to mean that we're going to get more of the work done. In other words, the amount of work that we could do is infinitely greater than our capacity to do it. So if we have
Right.
agents working on our behalf, it's not like we go, oh, the work got done, I don't need as many people. It's the opposite. It's okay, now those people can go do different work because there's never going to be a shortage of things to be done in most organizations.
No, and in fact, I would say it grows exponentially once you make efficiencies in the process. This goes back to, I think,
Yep.
something we spoke about many months ago, Jevons paradox. Let's bring it back
Yeah.
again.
Yeah.
When something becomes more efficient, then you wind up using more of it. And think about just our average day, how much time we spend on administrative tasks, things that just shouldn't really consume too much of our time, but do. And having the tools that are capable of doing so that rather focusing on the high value problems. And I agree. I think you're right. As companies automate some of this grunt stuff away or the smaller things away, with some of these tools, you're going to get a lot more done. It's just a
Right.
matter of fact. But that more getting more done at the end of the day creates more value. There's so much positive that comes out of it that it's you can't even I don't put a number on it.
Yeah. Now, look,
So
I think we have to acknowledge the elephant in the room, which is there will be companies that deploy AI in ways that are not benefiting some of their workers. Just like there were companies that deployed automated assembly lines or typewriters or any technology in ways that hurt their workers. Right.
well, I think you're right, and I know you're right. I mean, look, any major technological transformation has resulted in changes. It has to. I mean, look, you're making changes. Like when Ford came out with the car, I mean, was he thinking about the impact on those that were driving horse and buggy? No. But people always there's always a transitionary period of time before we embrace the new. And yeah, absolutely. I think during this transitionary period of time, there will be people that won't gain the benefit, won't have the benefit, it will hurt them more than it will help them. And I think that's unfortunately a natural outcome of this type of a change. It's
Yeah.
there are people that won't easily adjust, and it'll be a generational shift.
Yeah, there's always a period of disruption followed by some normalization. So
Right.
we had a very relevant question pop up in the chat. So I'll read it to you, and you can take the first whack at answering this. The question is: I saw an article where Bill Gates was quoted saying almost every job, maybe except coders and energy experts and biologists, but every other job would largely be impacted or replaced by AI. What are your thoughts on this?
I haven't seen a quote, so I don't want to comment on it directly, but I will opine on what I think about that question. I think AI is going to impact all virtually all jobs out there in some capacity. I'd say all jobs. There are certain jobs, obviously, that maybe AI is not going to impact, but certainly white collar thought knowledge worker jobs are absolutely going to be impacted. I have no doubt about that. Especially coders. I think it's going to have an enormous because we're seeing that in our day to day. We're seeing
Right.
the impact it has on engineers, just the alteration and efficiency and what they can do, and just the general approach to how they solve problems with code. And we used the example last week of, it was a project somebody's working on and how within spending 3 days of writing specs generated 6 months worth of code. on systems that they've never used before. So that to me is a level of efficiency that's just off the charts. Even things like biology and any energy experts, those are knowledge tasks. I can't see how you cannot change. I mean, there are so many demonstrations out there now of, generating new drugs or identifying new proteins. All these things that previously people thought could not be done with technology are now being done, or artificial intelligence are now being done. It's discovering materials in a way that we never been able to do. We would have never thought to put together, and it's finding ways to do things. So do I think it's going to impact all these? Absolutely. I think it's going to have a dramatic impact on all these thought work and these knowledge worker type jobs, these types of jobs, scientific jobs. It's artists, you name it. To me, it's going to touch everybody.
Funny that energy experts is one of the fields that Mr. Gates maybe pulled away from his, these will all be impacted, because just this morning I was reading an article that a firm I hadn't heard of before, I think they're called Earth AI, and they
Or
used AI analysis of satellite imagery to pinpoint the locations of valuable mineral deposits that
right,
were not normally visible, but somehow they were able to use AI to predict where mineral deposits would be found, and their early tests were very positive. So even energy experts are potentially in the crosshairs. I think it's also, you know, if you replace AI with electricity in that phrase and say almost every job will be impacted or replaced by electricity, it holds water, right? Every
right,
hard to think of
right,
a job that wasn't impacted or replaced by electricity. But we need to peel it back a little bit, right? Because there is the difference
right.
between impacted and replaced, right? Which is,
100%.
I think far more jobs will be impacted, changed, hopefully enhanced by the use of AI than just
Right.
outright replaced. And then there's also the every job angle, which is there will be jobs that still exist, albeit impacted by AI, they'll exist in a different form, but for
Right.
which we need fewer people doing them. There will be other jobs
Right.
where we'll need more people doing them.
Right.
And there
Right.
will be a
100%.
few jobs that just may not even exist anywhere anymore, in
Absolutely.
theory. Right.
100%. And I think when we started this journey, AI, it's great at, it's awesome at identifying patterns in data. It's fantastic at it.
Right.
I think where agentic computing takes it further, you go from that reactionary again to the proactive. Oh wow, now I can actually do something. I could act. I can act on systems. I can act on external things, and that's just an obvious next extension to just regular AI or just large language models or generative AI is being able to act on the real world and all these other systems
Yeah. Well, let's pick on
and
software
thinking.
engineers for a minute too, and then I want to go back and talk about tools because we talked about like screenshots as tools, but let's take software engineers in this argument about like who gets
Right.
replaced, because I think software engineers is a great example. We're seeing that. That's probably one of the first places we've seen the potential for real targeted significant disruption, because
Right.
you're already seeing, I think the CEO of Anthropic was quoted last week as saying that by the end of 2025, I forgot the exact percentage, but more than 50% of code to be written with the help of AI software. I know places where that's already true today. So
Yeah.
if you look at what that really means, and I know I've said this before, the vast majority of software that's written is not mission critical. It's doing tasks, it's helping people do things,
Right.
but it's not truly mission critical. It probably doesn't have extremely high requirements around performance or resiliency, etc.
Right.
Now, Peter, you're one of the relatively select small group of people who you have worked on mission critical applications that have really strict requirements, regulatory requirements, resiliency requirements, performance requirements, etc., right?
Right.
Like high
Right.
speed trading systems.
Yeah.
So if you pick apart software engineers, that we'll do the 80-20 rule, even though it's never 80 and it's never 20, but whatever the percentages are, the 80% of software that is kind of just like it does something but it's not mission critical, I think that
Right.
could, in many cases, that may be generated by AI, not by humans. The 20%
Right.
that is really important is always going to be human generated. Now, there may be AI helping to test it, AI helping to validate, but if I'm gonna be on an aircraft with a fly-by-wire operating system, I want a human. I want multiple layers of humans to have tested and validated and designed and built that system.
Yeah, certainly right now, absolutely. I think that's 100% true. I mean, I'm not going to test AI. I'm not going to use AI to go write mission critical performant, highly performant code that has to trade, $1 trillion in assets a day. I'm not. I might use it for certain parts of it, things that maybe are to easier, but reproduce or not as important to the core code. So I'll definitely use it to make me go faster.
Yeah,
Absolutely. But for the core part of that code, those mission critical type applications, I don't, yeah, I would still be doing that by hand. I do think, and this is one thing you and I had discussed last week, is using these tools. Like if I'm a person sitting on, and I always go back to a trading desk because that's where my experience lies. How many applications weren't written that could have been written that would have made their lives more effective with a tool like this? And
yeah,
I think that's you're going to see people who are not, and now coupled into that with agents,
great point.
you're making people or individuals that weren't as efficient, much more efficient, and letting them do it themselves. As long as you put constraints
Yeah,
around them, they can now go do it. So, oh, I can write a piece of code that does the following. It goes and scans the various news sources, and I see something, I'm going to go kick off a trade. And that's
that is
great. Let
a
them do it.
that's a great point. That is a fantastic point. I a couple of years ago, I read a book called "Automate the Boring Stuff with Python" or something, right? And it was all
Mhm.
about how to write little bits of code to automate things you do every day. There's a real world example that you and I are both very familiar with of where this has happened. That I think it proves your point that ordinary people will be able to use AI powered coding to write little apps that help them in ways that they
Right.
generally haven't before. And we're
Right.
seeing a little bit of this with this like whole low code, no code software development movement in general. But the
Right.
example I'm thinking of is Wall Street traders, right? Wall
Yeah.
Street traders are a particular group of people who tend to be very analytic, very studious, very intelligent. Like they have a set of, they have a
Right.
predisposition to being able to learn to code. And what we've
Right.
seen over the last decade is Wall Street traders, once they finally found the right tool, which for most of them was Python and Jupyter notebooks and things like that,
We'll code.
they have embraced coding. If you told
Yes.
someone 20 years ago that people sitting on trading desks would be producing large volumes of code, no one would have
Hmm.
believed you.
No,
But for the last 10 years, I mean, a lot of traders, a lot of people sitting on desks write code to,
I
as you
think
said,
it's
to automate tasks that they need to do.
I think it's mandatory to know how to code these days. And
Yeah,
again, couple in and keep going back to agent stuff, but the agent stuff ties it all together. It makes it so much more valuable than it was even in the
right,
past now.
right.
And because now they can have actions, they can do things proactively. And that's what they couldn't easily do before.
Yeah, exactly. And so I'm saying, like the Wall Street coders, they did it because a couple of things. One, they had the natural talent and disposition to learn a complicated coding language, and two, the economic benefit was there for them to do that. What
Right.
agentic technology will do is lower all those barriers. You need a far lower economic threshold to make it worth it, and you don't have to be willing to put in a couple of years learning Python if you can
Right.
use an agent. So the rest of the world may start using agentic technology to create little applications that do things for them.
Oh, I think 100% will. And those applications are
Yeah.
going to be big and powerful. And I think the other part, and I don't want to overlook this, and programmers, engineers have a mindset, an analytical approach to thinking. But I was talking to an engineer who was going through the process of designing a system, and his perspective was, it's given all the technology where it is today, writing really good description of the problem and solving it basically in English before you pass it off to one of these tools to generate code
Yeah.
is incredibly important. And in his case, made him seem like he felt like much more of an engineer because he was doing what was really the hard stuff. It's coming up with a way of solving a complicated problem, writing it down. So I go back to English skills are incredibly important to those that don't think they are, but they are. Being able to describe a problem robustly is incredibly important. And again, tying it all together with the language models, describing the problem that can generate the code, with having the agents behind the scenes to act on that stuff, is you can build a incredibly robust system for somebody who probably never wrote a line of code in their life.
You know what? 30 years later, well, more than 30 years later, I can now claim that there really was a method to the madness when I studied computer science and English literature, because you made it,
Yes.
you just gave me a way to defend that wasn't really such a crazy set of things to study. And
No,
yeah.
writing is important, really important. And I tell that to everybody. You got to be able to communicate this stuff. It's more important than ever.
So as a software engineer, it's really interesting because I think that a software engineer, um, yes, there will be fewer people coding, but again, that job doesn't just get replaced. It becomes the job of what you described as true engineering, which is
Right.
deeply developing a deep understanding of a problem, the solution, the constraints, and thinking carefully about what needs to happen to solve the problem and
Right.
articulating that in a way such that AI agents can actually translate those thoughts into code, right? So
100%.
you're just not writing code, but that doesn't make you any less of a software engineer.
No, it does, and they still think you're ultimately writing some code. If you're,
Yeah,
it's like any profession. Great engineers will always do the really hard problems. They'll solve the things that other people won't easily be able to solve, and they will take that code and they'll trim it, make changes to it, whatever. But they're still going to write some code. It's just going to be the
yeah.
stuff that's extraordinarily hard.
And I talked once to an architect who confessed that he even even in era of all of the computer aided design that's used in the architecture field for particularly very critical calculations, he still had a habit of doing them longhand just to double check. And
And trust.
right, and I think that's never going to go away. The more critical it is, the more human input you need, the more humans need to be in control, etc.
Hey, look, I still would, I still with a spreadsheet. I still pull out my HP 15C that's 35 years old and still double check the calculations.
Does it have RPN?
Yes, it does, and I still
Yes.
only I only like that. I will never use an old calculator. I'm sorry. I will never use a regular calculator. I will only use an RPN calculator.
All right.
It's so
Good.
ingrained in me. I can't get away from it.
And I'm imagining that there's probably a handful of people listening to this who wonder what RPN is, because I don't think, do they even make RPN calculators, new ones anymore? Just the old HP 15s, right?
Well, well, the 15s and the 12s, and I think you can
Okay.
also. I think you can take the calculator app on the Macs. I think you have an RPN mode on it. Um,
Now I'm going to
I
try
think
it.
so. Don't call me. I don't call me. I think you
Okay.
can. But yeah, no, I can guarantee most people have no idea what RPN is. But once you go there, you don't ever go back to anything else because it's just so much more logical and so much easier.
Right. You don't have to memorize the order of operations that has a
You don't
cute
need
little acronym next to it.
parentheses.
Right.
Yep. You don't need
Right.
parentheses. You don't need anything. It just makes it easier.
It just makes it's explicit, right?
Yes.
Like any good language would be. It's explicit and unambiguous, and that's
Yes.
what we should all be
Exactly.
striving for.
Uh-huh.
So listen, let's wrap here. But like we have barely scratched the surface of agents, right? And
Oh, yeah.
yeah. So I think one of the things I'd love to hear, after we wrap this up in the comments or emails directly if you prefer, but I'd love to hear, would you like us to talk more about agents? Are there specific things we want that we should cover? I know we would love to cover off how agents use tools, and
Right.
that's everything from APIs to something kind of new and cool called MCP.
Yeah. We can touch on
We're
that at
big on
all.
the we're big on acronyms today, but yeah.
Yeah, we are. Yeah, yeah, we are. And look, you know what? Look, again, David said, please ask questions, things that you'd like us to discuss in one more detail. We love, because as you can see, we love riffing and we can, we talk about anything. My natural thing is to talk about tequila, but we'll talk about AI today. Um, I Alice said, I think, look, questions are great. We appreciate questions. We certainly appreciate everybody listening. We hope we're imparting some knowledge. We hope you're getting something from this. We are certainly. I find the whole agent space fascinating, interesting, new, rapidly changing like everything else just in this whole domain. So it's interesting to see where it goes and where it turns out. But like David said, we've only scratched the surface.
Yeah,
So,
it's. I hope we spend more time talking about agents because it's such a fascinating topic, and I think at the end of the day, agents are the way that generative AI will impact most people in the world. And I
yes.
think that
Yeah.
at least as the current trajectory we're on.
Yeah, no, 100%. I agree with you. I think that's going to be, this is going to be the addition to already powerful technology that's going to make it far more powerful and impactful on everyday life. And
I
I think
guess
we're
I'd
only
like
seeing the beginning of it.
I do have to qualify what I said. I'm very sad to say there's probably one other form of AI that will impact people more than agents, and it makes me sick to my stomach to think about it. But it's
That is.
probably deep fake photos and videos coming out and being positioned as news and being put out in the blogosphere and on social media. I hate to say it, but that's probably, as horrific as it is, that's probably the most impactful form of AI currently.
I think it's going to have, and the funny thing is, I don't know if there's no easy way to stop that. And I know I always say this. It's generating false images and videos is not a new thing. I mean, it's been around for, 100 years. Governments have been manipulating photography and removing people and adding people and doing all sorts of things. It's just the scale at which you can do it now is mind blowing. And I think,
Yeah.
it's scary, but there's no easy way, I think, to prevent it from happening right now. And I think we have to be smart about what we see, because there are even times I look at some of these things and I am like, no, that can't be real. Um,
Let's have a
but
conversation about AI labeling, because that's for a future podcast. I think a lot of people have proposed that AI labeling,
yeah,
mandatory labeling of AI generated content would be the answer, and I wish I thought that was the answer. I think it's not the answer, and
no,
a lot of
no,
it goes back to what you're saying, which is there's all forms of image manipulation, ranging from when you press the shutter button on a camera and where you're standing to using AI to change an image.
and right,
AI
exactly. And
labeling is not going to be the answer.
no, I mean, look, Photoshop's been around for decades. I mean, it's the master image manipulation tool in the world. You don't know by default. You never know if what you're looking at is real because it's probably not.
Right. Yeah.
And you
So,
and I, both photographers, we manipulate images. We did it for a long time with our photography, so we know.
so, so the best inoculation is to be skeptical and inform yourself carefully, which is a whole other conversation we should have someday. But
Yes.
sorry for the dark turn at the end. But as much as I think agents are an amazing technology, they are probably only the second most impactful use of AI today.
Yeah, no, and I think you bring up a good point. We should, and we haven't, have these types of discussions about some of I don't say the darker implications, but the reality of it. We need to just put it out there because not everything is great. It's not,
You
and
might
nor
need
will
a
it ever be.
tequila for that. You might need a tequila cocktail in your hand for that conversation, because
I
it
am,
feels
I
like it
am
could get
all on
pretty
for that.
grim pretty quickly.
Hey, don't twist my arm. You know me.
Yeah.
I will happily put the bottle next to me.
All right. Well,
Uh,
listen, until next week, Peter, call me Data. And
yeah, David, thank you. Thank you to everybody else. I think, as always, an awesome discussion. I hope, again, please, any questions, feedback, always welcome. Do you not like the color of my shirt? Do you want me to wear something different? Happy to do it. Just tell me. But please, yeah, feedback is certainly welcome. And I hope everybody enjoys the rest of their day.
awesome. Thank you,
David,
producer
thank you.
Dave. Take care, everyone. Bye.
Have a great day. Bye now.